Hi everyone, I am Sapna Suman, a backend developer, and have an experience of almost a year and skilled in Java and Spring Boot. And this is my very first YouTube video. Hope you're gonna like it. So today I'm gonna talk about a few topics like Agile. What is Agile methodology? What is SDLC, which is Software Development Lifecycle? Some basics of Spring and Spring Boot. What is framework? Why we need framework? And we'll do some live coding and we'll see it later. So yeah, let's start it. So these are the few topics that I will discuss it today. Like I had already mentioned the Agile and software development lifecycle, or what about the Spring and Spring Boot framework and why we need it. What is API, types of APIs, what is web API, and what is REST standards, why do we follow it? And we'll talk about some other topics like IOC, dependency injection, Spring MVC, and we'll talk about few annotations like component, repository, service, and we'll talk about few layers also. Okay, so let's start understanding the software development lifecycle and Agile. First, we will understand it with an example. We'll not go directly to the definition. So suppose if this whenever we will get any project the product owner will give us about the idea of the project, what is the project, why we need it, what is the timeline for this project. So for this, suppose there is a project and it is containing we have 100 features to implement. Okay, we have 100 features to implement and the timeline is for, suppose it is for 6 months. Okay, so within 6 months we have to make a final product to give the client, so it should be client ready after the 6 months. Okay, so what we do usually, we divide it within a few specific time box. Okay, suppose we have decided few features okay, we have decided that for the first few week we will make three features or five features. Okay, and the second week we will make five or more features depending upon that, we'll decide it later. So the timeline we can decide it, we have 100 features to implement, and then our first timeline, second timeline, third, fourth, fifth, sixth, and this is seventh, and this is last of 6 months. Here there should be a final product. Okay, so for this we have to follow few steps we should have done all the testing, all the integration, whatever is needed to to work this application, functionality should be seamless. Okay, so within this timeline we have to understand the product also about from all the perspectives, from the user perspective, from an admin perspective, understand all the understand the product from all the perspective. Okay, the second could be we have to design high level design, and then we have to do low level design. Okay, and then we have to do development also. We will check all the APIs, we will test all the APIs, we will do unit testing. Okay, meanwhile we have to complete our front end also. Okay, so there will be integration part from all from the front end and back end. Okay, and then we have to deploy it also, and then we have to do load testing also, and many more testings are there. We'll talk about it later. Suppose these are the steps that we have to follow, we have to achieve it within 6 months. Okay, so what we can do, we can divide this project into few time boxes. So these time boxes are known as sprints. So this is the first sprint, this will be the second one, this will be the third one. Okay, this will be the third sprint. Okay, meanwhile these all will be fourth, fifth, sixth, and seventh. Okay, so suppose in the first sprint we are thinking to implement five features. We will implement five features, and then for this five features, for these five features, we will do all the testing. We will do all the testing. We'll understand about these features, how we can implement it. We can discuss it with our tech team. We will do high level design, low level design, and we will develop it. We will test all the APIs and we will deploy it. Okay, and we will do load testing, security testing, etc. All these kind of things we will perform it. And what we will do, at last of this sprint, if everything is working fine, we will just deploy it in our dev or in our production. Okay, so here we will do our first deployment. Okay, and if all these things are working fine, we can just walk through these all to the clients. These things we have developed in our first sprint. So is it perfect or not? If it is perfect, then the client will say yeah, it is working fine. You can move to the second sprint. In the second sprint, we can do the same thing. We can develop 5 or 10 features. We can implement it, and we will do all these things for this sprint also, and at last of the sprint we will deploy it. And another thing, like in the third sprint we will do the same. So this is a process for agile methodology. It is called agile methodology. And so yeah, this is agile methodology. And let's understand what is SDLC. So software development lifecycle. SDLC stands for SDLC, which is software development life cycle. It is also known as PLC, which is project life cycle. So it says there that from the start till end, how the software is built, like how we can do all the features, how we can organize it, right? So in other words, we can say it defines all the process of software development, covering all the requirements, analysis, design, development, testing, deployment, and maintenance also. Okay, so this is called as software development lifecycle. It is not like that product owner says that this is the product we have to build and we will just start a development. We have to go through all the process, and it provides various models like waterfall, V model, spiral, and iterative and agile also. And we are going to use agile methodology here. And yeah, so how we can define the agile? So it is a methodology within STLC that focuses on iterative development, flexibility, and customer collaboration. So it is a time box based iterative approach of development. Why we are saying that it is iterative approach? Because we are testing all these things for all the aspirants. So it is basically it is basically iterative approach. Okay, yeah, it includes Scrum, Safe, which is Scaled Agile Framework, Kanban, etc. And we're gonna use the Scrum. Okay, yeah. So that was all about agile methodology. Fine. Okay, what our next topic is? Our next topic is what is Spring and Spring Boot. So here I have already opened that. So Spring is basically a framework. Like whenever a developer or some programmer wants to build something, he or she doesn't need to develop it from the scratch. Suppose we have to develop two products. Okay, suppose we have to develop two microservices for one project. Okay, so this this is handled by one programmer and this is handled by another programmer. So for the project setup, whatever basic needs this programmer needs, the same thing is needed by this programmer. So the programmer has to so the programmer has to do all these things from the scratch, which will take unnecessary time. Okay, so yeah, the framework is like ready-made code, which you can use as a programmer or as a developer to build something, so that you don't need to waste your time to do things from the scratch. Because it's the basic things that we all have to do the same thing. Okay, so framework is like the framework is like ready-made code is provided to help the programmers. Okay, so there are two types of frameworks. Like we have okay, let me write it here. So we have two types of framework. Two types of framework. One is invasive, and second one is non-invasive framework. So the invasive framework is the framework which forces the programmer to extend its classes and implements the interfaces is known as invasive framework. Like we have EJB, I guess. Yeah. And the non-invasive frameworks, it does not force the programmer to implement its interfaces and extend the classes, is known as non-invasive framework. Spring, Hibernate are the types of non-invasive framework. So yeah, we have covered this also, like what is framework, why we need framework. And what is Spring and Spring Boot? Spring is also a framework, and like uh, there are many projects within the Spring framework which is already going on. So it also so the Spring Boot also like comes within the Spring framework only. It built on the top of that Spring framework. It is not a different project. It is the same project like within a Spring framework. Okay. So we have a Spring MVC, which is Model View Controller. I'll talk about it also, which is a Spring ORM, Object Relation Mapping we have, and yeah, many more projects which are going on under the Spring, and we can explore it here also. See here what we can do with the Spring. Yeah, we can use the Spring in many things. Like we can develop enterprise application, web application, anything from the Spring framework. Okay, it is reactive, batch, event driven, serverless, etc. It is built for Java. And yeah, for the Spring Boot, there are certain we have few advantages of Spring Boot. Like we don't have to externally configure the server. It has the inbuilt server, which is Tomcat server, and we don't have to configure the external server. Okay, this is all about the Spring framework. You can go through it. Okay, now let's talk about APIs, web APIs, REST standards, etc. So what is API first of all? So API stands for application programming interface. With the help, like it is a mechanism we can say that is used for inter-application communication. Like each time when you use any application like Facebook, Instagram, Netflix, or any other things, or you check the weather on your phone, so you are using the APIs. Okay, inter-application communication means like suppose we have this part and this part. Okay, suppose we have front end here. Okay, this is front end and this is back end. Don't go on that. My writing is not good. This is front end. This is back end. Okay, so here you have a login form. Okay. So here you take the name, you take the phone or email, whatever it is, and you have the option of login. Okay. So whenever you hit this login part, no, here you want to use the API, and here you will use it. Whenever you hit this login button, you want to use the API for login, which will take the name, which will take the phone number, and here all the business logic will be there. Okay. So yeah, we use the API everywhere. So let's talk about what is web API. So what is web API? So a web API is an interface that allows the communication between different software applications over the web. Web means web, like yeah, web stands and web API for web also already, right? And it enables application to request and exchange data using standard web protocols such as we have HTTP or we have HTTPS. And web APIs are commonly used to build RESTful or GraphQL services that allows client means mobile application or web application, okay, to interact with the backend system. Okay. So we have the types of web APIs like we have REST API, GraphQL, SOAP, gRPC, WebSockets, RPC, etc. Okay. So the application which is built using REST standards are known as RESTful application or like a RESTful application or REST application. Okay. Here REST stands for wait. Let me write it here. Here REST stands for represent representational state transfer. Okay. Representational state transfer. And like REST API follow a stateless resource-based architecture using HTTP methods. So there are certain characteristics for RESTful APIs, which some of them are it is a stateless. Stateless means what? Like all the APIs, all the requests will be independent. They will not depend on each other, and it uses HTTP methods. Uses HTTP methods like get, post, put, delete. We have patch also. Patch is basically used to modify a particular field of a record. Yeah, it is basically resource oriented. Resource mainly we can consider a user, product, or something, and it uses JSON or XML response format. Uses JSON or XML response format. Okay. So all the APIs, all the types of APIs that I had mentioned earlier, like right here, we have REST, we have GraphQL, we have SOAP, we have gRPC, we have RPC also, etc. The purposes are very different for all these kind of all these kind of APIs. Like for the REST API's purpose, we can say it is for used for general purpose, like for web and mobile application, and SOAP is basically used for enterprise application, like needing which needs high security. And the GraphQL we can use for app requiring flexible data, like data fetching, and gRPC for high performance microservices. RPC can be used for fast internal system calls. Okay, so yeah, these were all about APIs and about web APIs also. Okay. And let's go like let's do a live demo practice for to understand all what is inversion of control, what is dependency injection, and about this annotation. Okay, I have not created a project. Let's create a project here. I'll go to Spring Initializer. Here, your internet is quite slow. Yeah, let's create it here. Let's do everything as default, whatever is given. We will add some dependency, like we will add Spring Web starter. We can add and data GPA. Okay, let's add this. Whatever will be needed, we will add it later. Okay, so we'll generate it. And it is downloaded here. Let's go here. We'll just go here. Let's go to download. We can just extract files to our. I created a folder in Java internship. Let's see it. It's in Java internship, right? Okay. We have already extracted it here. Let's close this step also. We'll close this step also. As we have already opened the Eclipse, so we will import it here. Import project. We'll go to Maven project, existing Maven project. We will choose our directory here. Okay, the pom.html, XML, sorry. Finish. Here we can see the timing, like 9% is done already. 9% done till now. Yeah, it's 100% done. Let's talk about like let's go through it. Demo. Here we can see the folder structure of this. Like in the form.html will contain all the configurations, like all the dependencies we have. Yeah, right. As we have added like web dependency DPA. So here it will be, and it will be as a jar file. Like yeah, here we can see all these things. We have log4j also, logback also. These are the default loggers. Okay, and the entry point of the Spring Boot application will be here. Here will be written a main class, like here you can say the main method, which is the entry point of any application, and it is annotated with Spring Boot application. Okay, so yeah, let's create a new package like demo service. We will not interact with any databases. We will just create a simple endpoint package and then demo dot, not repository. We will go with the controller. Okay. So we have two packages, that service and the controller. Service contains all the logics, all the business related logics. And if you want to interact with the databases, write all the configurations in application.properties file. But the thing is, if you are mentioning all the URLs here, and when you want to deploy it, and like you are using Git-based, like for example, for code base. Like so, it is not a good practice to keep all the URLs here, like AWS configurations URL, database URL, because these are the important URLs. So we will write like we can mention that the URL is like not a URL, like the JDBC dot colon dot whatever it is. We will configure it in our environment variables and we will import it, but we will not mention a single URL which is important. Not we will not mention it here. Okay. So we have to keep it in my mind, and every like whatever I have learned in this 1 year, good practice. The people says no, then this is a good practice. This is not good practice. So these things, like it is important. These are the small things, but it is important, right? Let's create a class here, not class. We will create an interface here. We will create an interface here called demo, and we will create another package, new package, demo dot service INPL, which is stands for implementation. And here we will create a new class which is demo implementation, and it will implement. Not we will not implement it here right now. So we can create any abstract methods, like what abstract method we can use. Let's suppose we create a ref controller for adding two numbers. Okay. So we can specify it will return your integer sum, and it will take two number, integer n1 and integer n2, right? And we will again create a sub for integer n1, comma integer n2. Okay. We have two methods. Okay. Now here we are implementing implement control space implement demo. And if you will over here add an unimplemented method. So we can delete it by using control D if you are using Eclipse. So you can use the shortcuts like for the indentation. Suppose this method is here. So you can select everything at a time and use control I. So this is for indentation, right? So it will return you here n1 plus n2. And here we can write few logics like if n1 is greater than n2, then return n1 minus n2. Otherwise, return n2 minus n1. Okay. We will annotate this one as a service. And here, this one we can mention as a, I'm not sure, I have never used it. That's why. Okay, now we will create a controller, cancel it, and then create a new controller, new class, demo controller. We will annotate with it REST controller, and we are using the REST. Okay, we can use the request mapping also, and here we can mention calculator, and here we will create like we provide the abstraction. No, so we will try to write the reference of the demo. Okay, so we will write it private final demo, and we will yeah this is the interface, right? What happened? Achha, just wait. Okay, final means constant. It cannot assign other things. Okay, okay. And here we will use the auto wired annotation. I'll explain it. Let's create those methods first. We can create public and like for sum, and then return, we will use demo dot sum. Okay, and we will pass it here at the rate request param n1 comma at the rate request param n2, like int n1 and then int n2 n1 and n2. And it will be get mapping. I will tell you why we are using get mapping here, why we are not using post mapping. We'll just copy it for subtraction. Okay. So here I have created a controller and I am not mentioning the path here because I am already using request mapping, and here I have mentioned the like prefix for both of the API, but we can use it here sum, and then here as sum. So there will be difference between sub and sum. Okay, because both are the get mapping. If we use just use the calculator as a prefix, so it will be confusing to which API wants like should be accessed, right? So here I have created two APIs for the sum and for the sub, and we have created a service class which is implementing the demo interface. So if you will click here, no, if you will click here, so and you will go to open declaration. See, here you cannot go to the implementation part of the sum. You are just going to the interface, like where the method is declared. Okay. So it's the same thing if you will go here, like whenever someone will try to access those logics, they cannot access because he or she cannot see the logic behind that function. Okay. So it is a good practice to use the interface to like you know about the abstraction, right? Hiding the implementation, providing the services to interfaces or abstract classes. So this is the same thing. We are providing the abstraction here. So let's talk about few annotations that I have already mentioned here. Before that, I will talk about I will talk about like what is dependency injection, what is inversion of control. So the dependency injection, we can say it is a process of injecting the resources required. It is a process of injecting the resources required for an object during runtime to achieve loose coupling is known as dependency injection. Like here we are not writing like it should be equal to, as we know that we cannot create an object of interface, but we can create the object of subclasses like implementation classes. Here we are not writing like demo impl like I should write new here. Here I am not writing it, right? So it is not necessary to write it here because like suppose if you want to create many, if you have many implementation classes, so every time you will have to initialize it. So dependency injection provides you the way so that you don't need to write the logic to create objects. You can just tell them that yeah, this is the class that you have to create objects, and yeah, you have no, the Spring has to maintain it. So like in object oriented programming language, the dependency injection is nothing but the process of injecting the references of one object into another object during runtime. So during runtime, it will create the object of the demo implementation. Okay. And yeah, we can achieve it by the dependency injection by using Spring containers, which is present in Spring framework. So as we are creating the Spring Boot projects, yeah, but Spring also it is built on the top of the Spring Boot, So we use the Spring part. Okay. So let's talk about inversion of control. Inversion of control means like passing the control, right? So it is a process of transferring the control of creating the objects, and injecting the resources required for the object and managing the life cycle of an object from one part of an application to another part of an application, the same application, so that it can focus on another task, right? And we can transfer the control to Spring containers and the Spring frameworks, which is present in Spring frameworks. Like how, if we will just mention the auto wire, no, it will not work until and unless we will not see the Spring container, like the service annotation will say the container that this is the class that you have to maintain. Okay. So if we will remove it, no, and if we will try to create the object, like we will use the auto wire, it will not gonna understand. Like I have never used it like this, but yeah, let's try it. Okay, let's run this. We will run as maven build team spring boot colon. Run. Okay, I have not saved it. Save it. Why is this build failure here? We are not using any database URL, but why it is taking this? Wait. So yeah, the error is gone. The error was because I in the form.xml I was using that Spring Data GPA dependency, which was using that database configuration. So I commented it out. You can just select it and control shift slash. So it will be commented out. Let's run it again. Run its main build. Okay. Spring Boot colon run. So here we can see the Tomcat started on port 8080. Yeah, let's access it first and then we'll change it. HTTP colon. So let's access that. Let's see whether that is done or not. Yeah, it is done here. And let's create another method for this. We'll just use public health check and the return type will be string. Return. Okay. String the uppercase will be there. And it will be at that method. So whenever we will try to access this API, okay, for automatically loading, we have not added any kind of dependency. You have to run it manually. Let's hit it like this. Why is this error? Okay, yeah. Okay, so it is working fine. Now we will use this URLs like we'll use sum and we have to pass two parameters which is n1 and which is n2. So here we are getting the sum and if we will use its sub, we will get 2, sorry 8, right? Because we have written the logic here. Like here in the implementation part, we have written the logic here. If it is not like that, we just let's try to return it 0 here. Okay, we will have to run it again. Just use it. So this runs the last command, whatever you have done already. So it is started. Let's go and we will see that we will get 0 here. See, we got 0, no? This is 0, right? Okay, now if I pass it as 22, we will get 2. So yeah, it is working fine now. Now let's see how we can change the port here as it is by default running on port 8080. So how we can change the port? We can directly go to application.properties. We can go and use server.port equal 8081 or whatever you want to use, right? So you can, I'm using 8081. Fine. Let's go and run. So it ran on, started on 8081. So here